Think about the ways that we use the smartphones in our daily life. We reply to a message, browse the web, or post a photo to an SNS. Many of them are instant, short-lasting, frequent, and ubiquitous. We envision that these everyday experiences can be made stronger by virtual reality or VR, enabling immersive and wider views. We call these experiences instant VR, an enhanced mobile experience powered by VR while ensuring equally instant, short-lasting, frequent, and ubiquitous interactions, just like today's smartphone. Then, what devices would be suitable for the instant VR experience? So far, lots of devices have been introduced to use VR applications and services. One most popular type of device is tethered or standalone head-mounted displays, such as HTC Vive or Oculus Quest. These devices provide a high-quality experience and rich interaction with custom controllers and other accessories, but they are heavy, hard to carry, and expensive. On the other hand, mobile HMDs like Google Cardboard and foldable VR lenses also exist, which pursue high portability and thus could be suitable for instant VR experience. Although mobile HMDs have an advantage in high portability, they suffer from limited input methods. Most of them provide only a single primitive input method, such as a magnetic button or binary screen touch. Here are multiple controls in a mobile VR application. Without a special controller, the user needs to orient his head to point the target control. Only by then he can make a click, which can be inconvenient, distracting, and time-consuming. To address this limitation, we propose TouchVR, a mobile system that enables back-of-device interaction for rich input in instant VR, in an easily integratable form with existing apps. TouchVR supports instant tapping on 6 predefined back-of-device positions. Importantly, those tapping positions are identical with the natural resting positions of the user's 6 fingers when holding the phone. TouchVR-powered applications allow the user to make different inputs instantly without any head movements. Thus, the user can keep her focus on the content, not looking elsewhere to make an input. We implemented a prototype of TouchVR on the Android platform, compatible with Unity-based mobile VR applications. TouchVR basically works based on the smartphone's built-in inertial sensors, accelerometer, and gyroscope. A feature extractor and a pre-trained SVM classifier are used to detect and classify 6 distinct tap positions. To be easily integrated to mobile VR apps, TouchVR exposes its APIs to let app developers easily register an existing input handler method to a certain tap position. Because our system provides simple and easy-to-use APIs, we believe TouchVR can be incorporated into various instant VR usages. Suppose a mobile stock trade application enhanced by instant VR with extended display area concurrently showing multiple charts. As timely trade is extremely important, TouchVR can create multiple shortcuts to time-sensitive functions such as selling, buying, changing prices, and so on. In a multi-user chat application with avatars in a large virtual space extended by instant VR, TouchVR can help the user make different responses in a timely manner, like raising eyebrows, clapping, or thumbs up.